Alright, uh, good day. My name is Engineer Tolentino, and I'm going to present cable problem. Okay, this is a this is a non-symmetric parabolic cable. A uniform 80 feet pipe that weighs 960 pounds is supported entirely by a cable AB of negligible weight. Determine the length of the cable and the maximum force in the cable. So, okay, the first step is to model this what? To model this parabola. Now, that can be modeled by this equation, square root of y is a plus bx, where that square root of y is actually the distance, the vertical distance, okay, from the lowest point, from lowest point. This is lowest point. So just use the model Multitool. Okay, that's a straight line. When x is 0, okay, this is my reference A. Okay, I'll put negative square root of 20. And when x is 80, I will have positive 1, positive square root of 7.2. Okay, this is always negative and positive, left and right. Okay, then get the value of A, shift 151A, that is okay, that store it to A, and get the value of B, shift 152 equals, store it to B, and therefore we have the equation of the parabola as equal to y is A plus bx squared. Okay. To get the length is just equal to the integral of 1 plus the first derivative of this is 2 times A plus what? Bx times B, and then square, and then dx, limit from 0 to the total length of the cable. Horizontal length is 80. Then just okay, go to mode 1 and integrate that square root of 1 plus that is 2, let's start with B there, times A plus what? Plus B x, and then square, limit from 0 to 80. So you get that 86.02. The length of the curve is 86.03 feet. Okay. And to get the maximum force in the cable, of course the maximum force in the cable will what? Will be an A. So I want the edge there. I want the value of the edge there. Of course, this is the maximum force T. Okay. Now, to get this distance, that horizontal distance, alright, that is just the x-intercept. So, that is, okay, again, let's go to mode 3.2 again. Mode 3.2, again, let us model again. This is, okay, 0, negative what? Negative square root of 20, and what? And 80, that is what? Square root of 7.2, and then get 0 exact, shift 154, this is the x-intercept. Okay, so I'm sorry, x hat should be ship 154. I mean, that gives you 50. Therefore, this is 50, and the total value there is just 50 times what? 50 times 9. Okay, 50 times what? Uh, the total the total weight, or the uniform distributed weight, which is 960 divided by what? 960 divided by 80. So this is the same as what? 50 times 960 divided by 80, that is 600. This is 600 pounds. Of course, I need that uniform load, which is 960 divided by 80 again, with this distributed load, which is 12. So our W is 12 pounds per foot. And then remember, our H is WL squared over 8D. So H is W, which is 12, times L. Our L that we're going to use is double of this 50, which is 100 square over what? 8, and the sag is 20. So what is that? You get mode 1. This is 12 times what? 100 square over 8 times 20. Okay, it gives you 750. H is 750 pounds. Okay, and of course I can consider what? I can consider the other side. This is the other side there. This is your H, and of course this distance is 30. Okay, so my H is also equal to W, which is 12 times this times 60 squared over 8 times D, this time 7.2. What is that? 12 times what? 60 squared over what? Over 8 times 7.2 gives you the 750 pounds. Alright, this one. Okay, this verifies that computation, and to get that T, okay, this is just the resultant of 600 and what? And 750. This is 750. So resultant of 600 and 750, that is square root of 750 squared plus what? Plus okay, 600 squared. Alright, gives you the maximum what? Tension. So the maximum tension is what? 900 what? 960.5 pounds. Okay, 960.5